Okay, now moving on to the next numerical, that is in terms of Faraday, how much electricity is required to produce from molten CaCl2 20 gram of Ca, from molten Al2O3 40 gram of Al. So this is the question. Please read the question again, children, to understand the what the question is asking and what is the given information. The question is asking that again, how much charge will be needed to carry out this conversion, that is to carry out the conversion of CaCl2 into Ca metal, Al2O3 into aluminium metal. So obviously these two processes will be involving the electrolysis of the given salts. So we simply need to find out the change in oxidation state and the number of Faradays that will be needed. So from the given data, you can see here it is mentioned that Ca in, first of all, write down the formula of CaCl2, and you know that the oxidation state of chlorine is -1, and since you have two atoms of chlorine, the charge over it will be +2. So obviously to carry out the conversion of Ca2 plus to Ca, you will be needing 2 moles of electron, and 2 moles of electron again means you will be requiring a charge of 2 Faraday, which will give you the exact value of the charge when you multiply 2 into 96500, if you remember the value of Faraday. Now again, looking to the question, you can see here, children, that again the mass is also mentioned here. That is, you need to find out the charge required for 20 gram of calcium, whereas the calcium that is being deposited here is 40 gram, which is the mass of 1 mole of calcium atom, that is the atomic mass of calcium. So for 40 gram, if the charge needed is 2F, so obviously for 20 gram the charge needed will be 1F. So you can see the questions are very simple. The question based on Faraday's law is very easy. Now moving on to the next part. The next part says you have to carry out the electrolysis of Al2O3 and then to find out the charge required to convert Al3 plus to 40 gram of Al. Now again moving on to the calculation part. Here you can see that the conversion of the equation for the conversion of Al3 plus to Al is written here. The charge over aluminium is always 3 plus because it is the valency, if you know, and 3 moles of electrons will be needed to convert this Al3 plus into aluminium. But the atomic mass of aluminium is 27 gram and we need to find out for 40 gram. So again, following the unitary method, you can move to the final answer. As you can see here that for 27 gram of aluminium, 3 Faradays are required. Therefore, for 1 gram of aluminium, the required charge will be 3 by 27, and for 40 gram, it will be 3 by 27 into 40, as you can see here. And then you reach to the final answer. The final answer is, on calculation, you will get 4.44 Faraday.